Alright, good morning everyone, and welcome to another session in differential calculus. Today we will learn how to find out the derivative of any point on a parabola of x squared. So in particular, this is our example. It reads, find the derivative of a point A where x is 1, y is 1 on the parabola using the first principle of differentiation. So that's our question right there. Now, there's an easy way to do it, which I do not recommend, unless you know how it is derived. So we can say y is equal to x squared. That's our equation of this curve. So we can say that the derivative of y with respect to x. Now, if you follow the formula method or the power rule, it says that a n times x to the power n minus 1. So since our coefficient is 1, we can say 1 times 2 times x. The power is 2, so 2 minus 1. So derivative of y with respect to x is actually 2x. The power 1 is equal to 2x. And we're done. Okay? So let me show you how to do this using the first principle. Now, our answer was 2x, so keep in mind, okay? So let me write down the formula of the first principle, which is derivative of y with respect to x is equal to a limit of h approaching 0, where the fraction is function of x plus h minus function of x divided by x plus h minus x, where we can easily cancel out plus and minus x. I don't have to write this, but it's there. So point A. Where's the point A? Let me mark the point A. So this is point A, where the x value is 1 and y value is also 1. Now, in order to find out the derivative at this point, which basically means what is the instantaneous change in y at this point at a given x, or what is the slope of this particular point of the curve. So our a is 1 and 1, where the x is 1 and y is also 1, and we can also say that y is a function of x. Correct? There should be no problem at all. Okay? And we can also say that this is actually equal to x or x squared, because that's how we get y, x times x, right? Now, the most important thing you need to differentiate is another coordinate. You can take any coordinate of your own choice, but in my case, I'll go for point B, this point. So let me write point B. At B, x is 3 and y is 9. Okay? Now, so this is the x value and this is the y value. That makes up a coordinate. Okay? Why do we need the second coordinate? Because if you don't know the second coordinate, you don't know your h. And if you don't know your h, how will you apply the concept of limit to h approaching 0 to find out the first derivative of this point of the curve? So that's why we need a second coordinate. Okay? So the value of h here is actually more than or equal to 1, but less than or equal to 3. So h is actually 2 units here. It's 2 units. Now, why do we need to apply the concept of limit h approaching 0? Because we have to move this point. We have to move this point so close to this point that the difference is barely seen. But at the same time, there will be a difference, because if there's no difference between these 2 points, then there's no way we can differentiate them and find out the instantaneous change in y at that point. So how do we apply y equal x squared into the formula of first principle? Ready? But before that, have a quick look at this. So our x is 3. How did we get 3? So at this point is a point of x, and 1, 2, 3 is our h. So this point will obviously be x plus h. Correct? So we can say that x is actually x plus h, because this is the point 3. And this 3 is actually x plus h, because this is x and this is h, and this point is x plus h. So we can say that the x value is actually x plus h, and we know that y is a function of the x value, and our x value is x plus h. We can also write it like this: x plus h. And what is the function of x plus h? It means, how did we get 9? We get 9 by squaring x plus h. So we can also say that this is our y coordinate. Now, since we have this figured out, we can go back to the first principle, and it is going to be a piece of cake. Trust me. So let me write this down. Derivative of y with respect to x is equal to limit h approaching 0, a function of x plus h. So our function of x plus h is actually x plus h whole square. So we can write x plus h whole square minus our function of x, which is actually x square. So we can write minus x square divided by h. I hope this is very clear until this point. Next step, derivative of y with respect to x is equal to limit h approaching 0. I'm so sorry for my horrible handwriting. I know. I'm so sorry. What will happen if we expand x plus h whole square? It will be x square plus 2xh plus h square minus x square divided by h. So we can easily cancel out this positive x square and negative x square. So the next step will be derivative of y with respect to x is equal to a limit h approaching 0, and we are left with 2xh plus h square divided by h. Perfect. Next step, derivative of y with respect to x is equal to limit of h approaching 0, and we can take h as common, so it will be 2x plus h, right, divided by h, and then we can easily cancel this h out, and it will be left with derivative of y with respect to x is equal to limit of h approaching 0 and 2x plus h. Now, please understand that limit of h approaching 0. So when the value of h approaches towards where its value is equal to 0, then these 2 points come so close, they are close enough that the difference between them is almost equal to 0, but at the same time it is not equal to 0. There lies a little difference between them, and with the help of that difference we differentiate 2 points and we find out the value of the slope of that point on the curve. Okay, so if the limit of h is approaching 0, which means it is almost equivalent to 0. So our next step will be dy with respect to x is equal to just 2x. Because what is the point of adding a value of 0.00000000001? I mean, look at this number. It's almost equivalent to 0, but at the same time, it is also not equal to 0. And this is the gap. This is the difference between those 2 points on the curve. And that's how we differentiate and find out the first derivative of any point. So our answer is 2x, but what do we understand by the answer of 2x? So let's go back to our curve again, and this is our point A, where x is 1 and y is 1, and the slope of this point, which is m, is equal to 2. And why the value of m is equal to 2? Because at this point our gradient is 2x, and since our x value is 1, so if we substitute our x value, which is 2 times 1 equal to 2, that's how we get the gradient of 2. Now this gradient is the instantaneous change in y at this particular point at a given x. So that's how we find the first derivative of any point of a given parabola of x squared. So thank you so much for your time watching this video, and if you have any questions, then you can always put them down in the comment section below, and I'll see you all very soon. Once again, thank you so much.